So now that we have our plant material inside the retort, inside the still, it's time to add water. And if you note, we have a sight glass here. And this gives you the indication of the water level inside here. You'll also note that down here is a mark, and you never want to see water go below that mark. And the reason for that is if the water goes below that mark, it could burn out the heating element. So you always want to see water minimum at that level. So now we'll just put some water in here. We've got our plant material in there. The plant material is dry. And what we're going to see is that it's going to absorb some of this water as it goes in. And then as we begin to distill, it's going to absorb a little bit more of it. Make sure your valves are closed. Okay, so our water level is coming up. You can see it's here. See where it is? I want to get it to halfway up there. And again, the reason I want my water to be at that level, even though some of the plant material is going to be in the water, as the water begins to boil, the plant material is going to absorb some of that steam. So the water level will go down in here as we're distilling. So we can get a little bit more water. So here we probably have to double what we just put in there. We're looking at probably close to maybe 8 gallons of water is needed in there, is what I think. But this is the process. You know, I designed this still, it's been at least 20 years ago. Let's see, probably 1995, 1993, when I designed this. And it's been working ever since. We've got them all over the world. People like it. The original design was a 7.5 gallon. That would be half this size. This is a 15-gallon capacity retort. It's good. We built it initially in copper because of the benefit of distilling lavender in copper. You know, lavender, when you distill, if you would distill lavender in stainless steel or glass, the essential oil that comes out will have a sulfury smell. There are sulfur compounds that come over when you distill in glass and stainless steel. Copper eliminates those sulfur compounds. So when your oil comes out, it's actually sweeter to begin with. Even though you still have to age your oil, distilling in copper is beneficial. Or lavender. It's not beneficial for all plants. You know, if you distill geranium or eucalyptus, it would actually turn the essential oil green. So that's not beneficial. Of course, I've done that. I did that with geranium once. I distilled a bunch of it in copper, and it came over green, but then I got some citric acid. It was like a magic trick. So I had this container of green essential oil, and I sprinkled in some citric acid, gave it a shake, and cleared it right out. Better living through chemistry. How are we doing level-wise? Yeah, that's pretty good. We'll just get it a little bit more, just so we can get it up there. We've also had this particular design for distillation equipment built in stainless steel. But again, if you're doing lavender, I'd recommend this. The other thing about copper heats uniformly. Stainless steel doesn't heat uniformly. You know, if you had a temperature gauge and you would measure the temperature on your stainless steel retort, you'd see that some spots are hotter than others. Whereas copper is heats more uniformly. That's why it's always good to have copper base or copper parts in your cooking equipment, because it heats evenly. This should do the trick. Okay, that's good enough. Oops, now we're going to put the lid on. I've got my water in place. The water level is up to here. A little bit higher than normal. You know, right about there is good. I'm going to put the lid on now. And the next step is to attach the condenser. Now the beauty of this system, let me show you this before I close it. So you can take a peek in here at this rim. Okay, you'll see a gasket in here. That's going to keep steam from leaking out when we seal it. Now this does not have to be extremely tight, and part of the reason is this is copper. If you tighten it too much, you're going to bend the copper. And then once you start distilling, if you see any steam leaks, if there's a leak here, just tighten this a little bit. You get a leak over here, you tighten that a little bit. And once again, don't apply too much pressure to it. So now we have to set up our condenser. And if you look inside the condenser, you see it's a coil system with an open top. And I designed it with the open top because some people like to do this outside. If you do it outside, you don't really need to pump water in. You can fill it up and then add water into the top to cool down the system, and the excess warm water will pour out here. Anyway, that's just for outdoor use, but the open top also helps it cool down a little bit. So now we're going to put some water in here. Make sure the valve is closed, right? There's an open and closed valve. That's for cleaning, for draining. Make sure the valve is closed. Then I shall get some water here. So what the condenser does is the steam passes through your distillation, through your plant material while you're distilling, comes through the bird's beak, and again, this is all stainless steel, there's no rubber or any other components in there. Then the hot steam enters the top of your condenser. This water is, you don't want to put ice in there. Some people think you have to put ice in there, but that's actually a mistake when you're distilling essential oils, and again, the reason for that is if it's too cold, because of the specific gravity of the essential oil, it makes it more difficult to separate from the water. So you want your distillate, when it comes out here, to be at about 110 degrees Fahrenheit, anywhere from 100 degrees. I go between 100 and 110. Give yourself some flexibility. And that way you know that when you use your essentiate, that the oil is going to float on the surface. So I'm going to fill this up below this hole here because we don't want the water leaking out. There are different types of condensers. This is a coil, but you'll also find that there are condensers that are vertical tubes. So if you can imagine a cylinder, and inside the cylinder are, let's say, 6 half-inch tubes. Well, that's your condenser. The water circulates around those tubes. The distillate goes through the tubes, and at the end of the day, it comes out of your condenser. Has a essential oil and hydrosol mixture. Okay, so that's pretty good right there. Fill up this container because we're going to need that for running the pump. Make sure water goes in and then water comes out. So in order to establish the condenser so that it's a cooling system, what you will do this is a small pump, just like a pump you would use in a fish tank. And it's adequate enough to make the water flow in here. Again, we don't need a great deal of flow because we're going to be able to change the temperature of the water as we go. Just keep it moving. And here's what happens. When the steam comes in, the top is very hot and the bottom is cool. So by circulating the water, you even out the temperature inside the container. So we are going to wait, but what we'll do now, let's get a screwdriver. Now this is the pump. This is going to be in the water bucket. And when you set up your condenser, you always put the water in the bottom. And again, because the water in the top is going to be hot, the water in the bottom is going to be cool, and it's going to push the hot water out of the top hole. So I'm going to attach this. Now this you want to have it on tight because you don't want to pour water all over the place. Then again, if you have a leak, you just remember it's just water. So if you're in an environment where you're not worried about the water hitting the floor, and if you're distilling, you shouldn't be concerned about that because it's going to happen. So, but it's good to seal this up so you can just get the water in there. This is electric. So the hose goes right in as far down as you can get down to the bottom. Then I'm going to plug it in. I'm not going to use my wet hand, I'm going to use my dry hand. Now we got water coming out the other way. Going in the wrong direction.